This is a computer?
That's exactly right. It's just a window dressing at one point, and now it's this is one of our standard flagship products. It's an 100-inch diagonal, true multi-touch printing screen. Now, most of this audience is probably familiar with multi-touch means nowadays, but to reiterate, multi-touch is the idea that a display device can actually accommodate more than one touch at a time. Your standard touch screen can pretty much only do this, but with this device, have an arbitrary number of contacts being sent at a time. Not just 2 or 3, but literally 10, 20, even 40, as many people can really reasonably fit together. This is also a pressure sensing device, which means I'm holding just a Sharpie here and able to use fingers, styluses, whatever you're most comfortable with. So what can we start to do with devices like this? Well, I'm going to give you just a tip of the iceberg peek at what a real state-of-the-art multi-touch display device and the associated graphics engine.
Now, it's very obvious already just now when you were doing what you were doing. The mouse and the menu is wherever you are. And so somehow, what was that gesture that you did?
That's exactly right. The first thing we realized when we were developing multi-touch is that you couldn't use, we had to throw away and rethink a lot of the standard desktop metaphors. For instance, you saw me, I invoked a gesture, which we call a loop here, to invoke our main menu. Now, the reason is that I don't want to keep going down to the lower left-hand part of the screen to press the start button every time I want to invoke a new command. So we came up with something.
Come on, now, it's not just the start button. You got us here.
I don't want to go up there for the Apple menu either. Or the button over there. I want something that's locally invocable wherever I am on the display that multiple users could perhaps invoke locally. That's easy to do once I know how to do it, hard to do accidentally. So that's where we just first start. These are the kind of fundamental rethinking of interfaces that multi-touch is just an enabler for. So this is our little just demo app that shows a few of the raw data strokes. The canonical example of what you can start to do with these kind of interfaces, of course, is the map. Now, we've all seen interactive maps before. Google Earth is very, the most accelerated program on the desktop right now. And typically with a mouse, you would have to be able to just manipulate 2 degrees of freedom at a time. Of course, if you wanted to rotate or zoom in, you'd have to maybe switch to another magnifying glass tool, or you maybe have to press right-click or shift control something. But with something like this,
your window doesn't have to be orthogonal, does it?
That's right. Everything is completely a full 3D graphical context. None of that kind of old barriers to okay, we have to keep everything in a rectangular format. You don't have to optimize line drawing for those kind of things. We know that mapping and geointelligence is a big part of the application area for this, so we developed a pretty sophisticated map engine at this point. For instance, I can not just load one data set, but perhaps 2 at the same time, or 3, and composite them together in real time. This is actually taking multiple disparate data sets that each might be a different projection. Do another one, and of course, let's take an overlay. So this is literally a composite of multiple data sets being together, and there are shaders being used because each of these was taken by different cameras, different flyovers, and to do that kind of pixel accurate registration on the fly is something that we've only do recently. And so it's really quite fun and amazing what you can do when you apply graphics, again, to real UI problems. So, of course, that's just mapping. Actually, what's the neat things I want to also show here is that multi-touch is also really interesting when you make it on a large scale. Not this kind of 30-inch kind of stuff. Because what's really neat about multi-touch is inherently multi-user, especially when you make it this large. So, for instance, I can drag out that lens again, and let's tap into a different data set. This again happens to be hyperspectral imagery. The government actually takes multiple infrared wavelength pictures of what's going on too. It goes a little bit beyond Google Earth, and it's used to classify ground usage, whether it's vegetation or urban or water basing. But I can tear this off, for instance, and I can hand it off and have somebody else, a colleague, be able to also navigate and use this device at the same time. It allows for the first time multiple users to work together collaboratively. So it'd be great if you can show everybody here where you live.
Well, that's, holy cow.
And of course, he could be doing that. I could be working another data layer. I could decide to go off somewhere else.
Jeff, my family's in the audience, and they'll tell you the reason why I can't tell you is because I'm not sure. I don't want to tell you. Can I just type something in?
can, of course, bring up the virtual keyboard here like that. One of the neat things about multi-touch is that it can pretty much be used to simulate down almost to be able to traditional interface. So let's, let's do a search on you anyway and see what comes up here. Go online, let's see what's there.
Hey, that's a good-looking guy.
Now, by now, we're all familiar with the standard two-finger or n-finger cam zoom rotate function. Basically, a two-dimensional object here has 4 degrees of freedom. 2 for translation, 1 for uniform rotation, 1 for uniform scale.
Hey, honey, am I going the right way?
No.
Of course, multi-touch really can go way beyond that, so let's perhaps look at it. And what I can do... Because what I'm actually doing is taking a raw triangle mesh that's textured in this case and actually manipulating the vertices of that mesh in real time without defining a skeleton or a backbone. So here I just did a raw version without the texture. And what I'm actually doing, and a lot of the way multi-touch or direct manipulation philosophy is about, is saying, look, let me rip these triangles directly with whatever fingers I have and say, I want to move these guys here. And the algorithm really tries to work with the rest of the triangles and fit it there. And that's what causes things to become visually plausible or feel natural, because it's very much the way, a device out there,
That twitch is starting to bother me. This could damage me for years.
Now, this, of course, is we're basically able to animate or sculpt you, just like you're made of clay. And these are, if you did this in a normal mouse-based interface, I have finally have done, once you have the proper high bandwidth input device to actually control this many things at the same time. And the graphics capability now is there. It's so exciting to do this, but we're now bottlenecked by the mouse. We could actually now, what happens when you have multiple objects that you can control each of their parameters with. And this is what we're starting to unlock here. There's just a lot of latent potential that graphics has now that we're just not tapping into yet with existing input devices. And this is our hope. This is what we've been working on in our research.
And Jeff, how do you see this technology manifesting itself into personal computers, our personal computers that we know today?
Well, like a lot of technologies, this stuff is going to start at the high end. Like the mouse did, for instance, it was used primarily back then for CAD and other really high-end, very specific engineering applications. But technology curves have become shallower and shallower. That this stuff, of course, our primary customer base are things like defense, military, creative applications, artists, tool users. But we're going to see a much more rapid migration of this, trickle down of this kind of technology down into the home. I believe really soon.
So I can obviously imagine us having something like this in our boardroom or our conference room, where engineers could be working together, we could be diagnosing a chip, or we could be studying something together.
That's exactly
all networked together?
That's exactly right. We can have multiple units networked across locations there. That's fundamental. Our scene graph is fundamentally about having to be able to synchronize these and work collaboratively. Not just co-located collaboration, you and me, multiple people working together in this life, but even across networks. And that's the other really cool thing that this is unlocking in computing. Computing has always been personal computing, you and the computer, just by yourself. And nowadays, computers and graphics are rich enough to really accommodate this collaboration between multiple users around. It's not personal computing anymore, it's visual computing, it's computing together. And really the bottleneck now isn't how much one person can do, it's how can we really have multiple people working together effectively.
This is really, really amazing. Jeff, thank you very much. Well, Jeff is becoming a somewhat of a global celebrity. He's as close to a celebrity as an engineer will ever hope to achieve. Thank you, Jeff.